Hey, these are the problems you all asked for page 67 in section 1.3. First is number 45. We want to find the limit as x approaches 2 of x to the third minus 8 over x minus 2. Direct substitution in the denominator gives us a 0, so we've got to try to do something. And this would be a factoring, and we're going to factor that sum of cubes that we wrote down the other day. And I'll put it up here for us. This is something that I do not give you this year, so we do need to know this. So A is x and B is 2, because those are the two things that got cubed. So we can rewrite this by factoring the sum of cubes. So it's x minus 2, a squared, plus ab, plus b squared, all over x minus 2. And then it's so nice that these cancel out or divide out. So when you write what's left, you have x squared plus 2x plus 4. And then we could do direct substitution. So it's 2 squared plus 2 times 2 plus 4. So 4 plus 4 plus 4 is 12. Next was 47. When x approaches 0 of x over x squared minus x. Well, I see everybody has an x, so I could just take everybody down an x, but I think I'll be a little more mathy and show my step a little better. Leave the numerator over, and let's factor the x out of the bottom. And then we'd say, oh, those x's divide out. Oh, I forgot to say from the very beginning, we would try direct substitution, and you'd get a 0 in the bottom here. So we got to try to factor or divide out. That leaves us with nothing in the top. No, not nothing. A 1. And an x minus 1 in the bottom. That's what I really want you to be careful of. Yes, it looks like there's nothing up there, but there's really that 1. And then we can try direct substitution. Negative 1 in the bottom. 1 over negative 1 is negative 1. The other way you might have done it is you might have said, I'm going to take an x away from everybody. That leaves a 1, an x, and a 1. So that's, you could jump straight from there to here. That's what we did with those delta x's in class today. All right, next, 753. The limit of x approaches 4 of square root of x plus 5 minus 3 over x minus 4. Can't just plug a 4 in because you get division by 0. So we're going to multiply by the conjugate of the top. Most of the time these conjugate ones seem to have a square root with them. Alright, and when you multiply the conjugate, we'll just do first minus last. When you square x plus 5, you just get x plus 5. And 3 times 3 is 9. All over, just leave these in parentheses. Don't factor them. Distribute, don't distribute. Just leave them multiplied together like this in parentheses. This top, 5 minus 9 is negative 4. So this cancels out with that because that is really x minus 4 up there, right? So that cancels out. So write down what's left. It's your simplified limit. 1 over the square root of x plus 5 plus 3. Now at this point, you've changed it a lot from how it started. So now let's try direct substitution again. Square root of 4 plus 5 plus 3. 4 plus 5 is 9. Square root of 9 is 3. And 3 plus 3 is 6. All right. 55. square root of x plus 5 minus square root of 5 all over x. Can't plug a 0 into the denominator. You get division by 0. So let's multiply by the conjugate. Square root of x plus 5 plus square root of 5. So that gives us the limit as x approaches 0. First, square root times the square root frees what's underneath, minus square root times the square root frees what's underneath, and then put the x and then do parentheses and do all of this. Now let's look at that numerator a little bit. Plus 5 and minus 5 is gone. There's nothing left there but x, and x over x divides out. So then you're left with a 1 in the top in your denominator. Now you've done a lot of simplifying and you've written down what's left. So now let's try direct substitution. Try to plug that 0 in. Well, this is basically just square root of 5. So what's 1 square root of 5 plus another square root of 5? That's 2 square roots of 5. And I'm okay if you leave it here because most of the time throughout this year, the book is going to leave square roots in the denominator. But I've heard they may have gone ahead and rationalized it. So this is an okay answer also, because these multiply together for 5, plain old 5, 2 times 5. But I'm perfectly happy with that answer. 59. So from the 2 classes, these are just problems y'all asked for. Limit as delta x approaches 0 of 2 parentheses x plus delta x minus 2x all over delta x. Can't do direct substitution because you get a 0 down here. So we have to try to do something else. So why don't we distribute here? So you get 2x plus 2 delta x minus 2x all over delta x. You just kind of want to treat delta x as if it was a y. As if, I know you're writing 2 things down, but it's one thing. It's the variable, and the variable is delta x. So just treat it like it was just a y, and distribute with it and everything. Plus 2x and minus 2x cancels. And you're left with 2 delta x over delta x. And we can do the dividing out thing. We have a delta x in the top and the bottom. Or you could have, at this step, you could have said, well, this is all I have left, and that's a delta x and that's a delta x. Either way, you're going to jump to this answer. All that's left is a 2 in the numerator. And there is no place to plug a delta x in. There is no delta x. Your answer is just 2. This is one of those basic limit properties from the second day of class. One of the first 3 properties that you had. Oh, it's this section. Excuse me. Sorry, I'm yawning. This section, the very beginning of section 1.3, we had the limit of b as x approaches c is b. If you want to look back at those basic limit properties, you'll see that one, and that's what we used right here. All right. 63 is the next one you all asked for. So it looks like I'm trying to use this rule. That makes it trig limit sine x over x is 1. And it's almost there. It's just I've got this 5 here. It's kind of messing it up. But that 5 is just being multiplied by the x. And there's really a 1 multiplied by that sign. So if you look at that as a 1/5 being a scalar, we can bring it out in front of the limit. So if the 1 and the 5th come out in front of the limit, you're left with sine x over x, which is this exactly right here. So all that I just boxed in goes to 1. So it's 1/5 times 1, which is 1/5. All right, the very last one you asked for was 71. I have not worked this one in a while. Let's see what it does. Limit as x approaches pi over 2 of cosine x over cotangent x. Well, I know a rule about cosine, but it's 1 minus cosine x over x. Or, I'm not sure if I told both classes, it's also x over 1 minus cosine x. It can be flipped. Limit as x approaches 0. This is 0. This is also 0. But I don't really have that. So in class we did a trig identity with tangent the other day, and tangent was sine over cosine. We also have a trig identity with cotangent, and cotangent is cosine over sine. So why don't we try to do that? Equals the limit as x approaches pi over 2 cosine x over cosine x over sine x. Don't lose where that original division bar was. So it's this fraction divided by this fraction. So we're going to keep change flip right here. So flip sine x over cosine x over. And don't forget that this cosine x that's right here is, I don't know where to put it, is over 1. So let me just rewrite it maybe. I'm afraid it's just a little too messy. So you had a cosine x, so it was all that was left, and you flipped and multiplied by sine x over cosine x. And don't forget we can make cosine a fraction by putting it over 1. So when I multiply, if there's something that's the same in the numerator and the denominator, they can divide out. So you're left with a sine x in the top and nothing but a 1 in the bottom. So you can go to the calculate screen on your calculator and do the sine of pi over 2. And you would get, let's see, pi over 2 is right here, and that's the 0.0. And you'd get 1. All right, if some of these don't make sense, I still, even after watching this, please don't say, oh, well, I'll never get it. Please just come and see me Monday morning before school and let me help you on it.